Good morning, students. Welcome back. I would request you that you mute your mic and all so that you can hear me properly. Now, we are starting with your triangles chapter from your geometry unit. Right? Why I have started this? You will be getting a video also related to that. But I wanted to join you all in on live session for this chapter. Okay. Now, in triangles, we know what are the properties of triangles. What is a triangle? There are several types of triangles visible to us. We all know that. Right angle triangle, equilateral triangle, isosceles triangle. These are all triangles, types of triangles we have studied in lower classes. Clear? In 9th class, you have also studied about congruency in triangles. When two triangles are congruent that means equal in shape and size. There were types of congruencies that you have studied. Right angle triangle, all sides are equal, all angles are equal. These are properties of triangles you have done. Right? Now, here in this chapter in class 10, we are going to discuss about similarity in triangles. Now, before discussing similarity in triangles, we will discuss about similar figures. Clear? When we talk about similar figures, all of us sitting, joining with the live class, or all of us in the school, right? We are human beings. We have a heart, we have 2 eyes, we have 2 hands, we have 10 fingers, toes, knees, legs and everything. We have similarity. We are similar. But when we talk about our size, it is all different. My size is entirely different from yours. Yes, my shirt size will be different from your shirt size, definitely, but will it be of the same shape? Definitely, there is going to be a collar, there is going to be cuffs, there is going to be sleeves, there is going to be a pocket. Everything is similar, but it is different in size. Shape is same, size is different. When we talk about this board in front of you, it is a rectangle, we all know. Right? You must be using your mobile phones for your live class, or you must be using your laptop or a desktop. The screen in front of you is again rectangular in shape. Yes, both of them are rectangles. This whiteboard is a rectangle. The screen that you are using is a rectangle, is again similar. But is the size the same? No. I am using a desktop for a live class. I am using a mobile for a recording. Is the screen size same for this board? No. The screen is rectangular in shape, but board is also rectangular in shape, but the size is different. Yes, shape is same, size is different. When we talk about square, one square, all sides equal, and this is another square, all sides equal. Both of them are squares, but are they congruent? Are they equal in shape and size? No, they are not congruent. But are they equal in shape? Yes, they are similar figures. They are similar figures. When I talk about my palms, right? Both of them are equal in shape and size. They are congruent. They are congruent. My all fingers are respectively equal, corresponding fingers are equal, thumb is equal in shape and size, my palm in between is equal in shape and size. But if I compare my right hand with my teacher, co-teacher, another one over here, or anyone at your home, you can compare it with your parents, with your sister, younger sister, elder sister, brother, whatsoever, you will find that the shape is same, but size is different. Your sister or your brother also has a palm, 4 fingers are there, 1 thumb is there. Their shape is the same, but size is different. Isn't it? So that is called similarity. But if you compare it with your right hand and left hand, they are mirror images, exactly equal in shape and size. So we say that they are congruent figures. Right? So here, students, what we are going to discuss, we are going to discuss about similarity in triangles. So you understood by similarity, what do we mean by similarity? That they are equal in shape but different in size. For example, you must have seen Taj Mahal. Some of you, I have not visited Taj Mahal. It is 7th wonder of the world, we can say. I have not visited. pictures, I have seen dummies of Taj Mahal at my friend's place. A small Taj Mahal, replica of the Taj Mahal kept on his dashboard for a showpiece. Right? Is it congruent? Is it equal to the original Taj Mahal? No, it is not equal. They are similar. The Taj Mahal, original Taj Mahal has 4 corners, 4 gumbajas, you can say, 4 pillars on the sides. The replica also has 4 pillars. There is a dome on the top. The replica also has a dome on the top, but the size is different. Shape remains the same. Right? So that is similarity in triangles. If you look around your home, sitting at your places, you're sitting at your homes, you're looking around the things, you'll find several number of similar things and several number of congruent things. Clear? When we talk about congruent figures, say this is one square of side 2 centimeter and this is another square of side 2 centimeter. Correct? Are both of them congruent, equal in shape? Definitely both of them are square. Are they equal in size also? Yes sir, both of them are 2 centimeter. So size is also equal. We say that they are congruent figures. But if I draw another square of side 1 centimeter, is it congruent? No, it is a similar figure. So what can we see? In congruent figures, angles are equal, all the vertices are 90, and sides are also equal. Sides are also equal. But when we talk about similar figures, angles are equal. Angles are equal, all vertices are 90, but the sides are not equal, they are proportional. Proportional we call it, or we call it same ratio. For example, what will be the ratio of this side? 1 and this is 2, so the ratio will be 1 by 2. Ratio of this side 1 by 2, 1 by 2. Are the sides in the same ratio? We say they are similar figures. Right, students? Now here instead, so we can see that when we are talking about congruent and similarity, there is a difference. In congruent, angles are equal, sides are proportional. In similar, angles are equal and sides are proportional. In congruent, angles are equal and sides are also equal. So if you observe your exercise 6.1, it is just based on that. It is based on that, what are similar figures and what are congruent figures. It is just asking you that. Page 122, exercise 6.1. Fill in the blanks using the correct words given in the bracket. All circles are, definitely circles can be of different shapes, different radiuses. We have done areas related to chapter. So they are similar, not congruent. Right? Then all squares are, definitely we just saw squares. All squares are similar to each other. Are congruent figures similar? Can you see the sign? Congruency, that is equals to, and this curve, spiral. They are similar, but similar figures are not congruent. Okay. All triangles are similar. What kind of triangles? Equilateral triangles are similar, of different sides. 2 polygons. Now polygon, what is a polygon? Any closed figure having more than 3 or more than 3 sides. So is triangle is polygon? Definitely. Is square a polygon? Yes. All of them are polygons. 2 polygons of same number of sides are similar if their corresponding angles are equal and their corresponding sides are proportional. Now the word corresponding, if you remember, you have done corresponding in class 9th. C, P, C, T, corresponding parts of congruent triangles. Yes? So that was CP, CT. So here also he is talking about the same. Just check third question. State whether the following quadrilaterals are similar or not. So you can see one is a square, one is a rhombus. The sides are proportional. Good. 1.5 by 3, 1.5 by 3, 1.5 by 3. The ratio is 1 by 2, 1 by 2, 1 by 2. But the angles are not equal. In square, all vertices are 90. In rhombus, opposite angles are equal. So they are not similar. So on page 123, you will find similarity of triangles. Page 123, two triangles are similar if their corresponding angles are equal and their corresponding sides are in the same ratio. Similarity in triangles, page number 123. It is given angles are equal, corresponding angles are equal, and corresponding sides are proportional. So your chapter similar triangles is based on this similarity in triangles, students, and that is what we are going to discuss today. Your first property of this chapter, Basic Proportionality Theorem, BPT in short we call it, or we also call it Thales theorem. Clear? We also call it Thales theorem. So this is the first theorem that we have to prove in this chapter, theorem number 6.1 of your textbook, Basic Proportionality Theorem. In short form we call it what? BPT. In other words, it is also called Thales theorem, and it is on page number 124 of your textbook. Page number 124 of your textbook. You can see that. Okay, I have proved that theorem. There are 4 theorems in this chapter, out of which one theorem is being deleted. Sorry, not one, 2 theorems. That is area theorem 6.6 and converse of Pythagoras theorem 6.9. Okay, but 6.1 and 6.8 we have to prove it. It is a part of our syllabus. Clear? So that is what we are going to discuss over here. We are going to prove basic proportionality theorem, and then we will apply it. Then we will come down to the verification, to the application of the theorem. Now, basic proportionality theorem, as the name suggests, proportionality. Two sides are proportional. What is the figure? I am drawing the figure for you. It is given in the textbook. I will use the same figure, same nomenclature, so that you can verify it later also. In triangle ABC, right? If a line is drawn, I am reading the statement from your textbook. If a line is drawn parallel to one side of a triangle, say this line DE is parallel to the side BC to intersect the other two sides at two distinct points, different points. Can you see that? It says if a line is drawn parallel to one side of a triangle to intersect the other two sides at two distinct points, the other two sides are divided in the same ratio. The other two sides, which are the other two sides? AB and AC. The other two sides are divided in the same ratio. So what is given to us? We are given triangle ABC in which DE is parallel to BC. What we have to prove? We have to prove that the other two sides, which are the other two sides? AB and AC are divided in the same ratio. That is AD upon DB equals to AE upon EC. Construction. We will have to do a construction. Now the question arises, sir, what and how? Okay. What and how? Observe. In geometry 9th class also I told you to observe the things. It will be the best part. Okay. You will write down in your notebooks, you will write down theorem 6.1, basic proportionality theorem, and the statement you will copy it from your textbook. It is given to you in your textbook. Page number 124. It says if a line is drawn, DE is drawn parallel to BC, one side of a triangle to intersect the other two sides at two distinct points D and E. The other two sides are divided in the same ratio AD upon DB equals to A upon EC. In exam also it will be written prove that. So you need to learn the statement, and this theorem is applicable in the entire exercise, entire chapter. Okay, it says if one line is parallel to one side of a triangle, the other two sides are divided in the same ratio. But the question arises, sir, how this happens? Agreed, but how and why? That is what we are going to prove over here. How? Pay attention. We are going to join the vertices D to the vertex C and D to the vertex E. Clear? And from D, we are going to drop a perpendicular. Sorry, I'll draw it with a dotted line so that you can see that it is the construction done. All the construction should be dotted line. Correct? This is perpendicular on AC, and this from E, it is a perpendicular on E. I'll name it as DM and DEN as it is given in your textbook. DM is perpendicular and EN is perpendicular. What construction we have done? DM perpendicular on AC, EN perpendicular on AB, and join D to C and E to B. D to C and E to B. Okay, now proof. Now we come down to the proof. In 9th class, I had shown you that these are the 4 steps for doing geometry. Figure, given, to prove, construction if any, and then comes the proof part. Every very important part. You have to give the reason for everything. Alright, so take a look what we want. We want AD and DB. So where is AD? This is AD and this is DB. On which arm of the side of the triangle? AB. Triangle ABC, we will concentrate on this arm. On side AB. Please check. Please check. On side AB. We want AD. Just observe this AD. Is this AD a part of triangle ADE? So what is the area of this triangle? Half into base. And is this the height EN? On this side AB? And second, we want DB. Where is DB? So this is DB. Area of triangle BDE. This triangle. Here, base is DB. So which is the height? There is no perpendicular. This EN is going to be the perpendicular because EN is perpendicular to AB. This is an obtuse angle triangle. I am drawing the figure for you. This is D, E, and B. This is an obtuse angle triangle, and in an obtuse angle triangle, the perpendicular always lies outside the triangle. You must have been taught in lower classes. Okay. Don't worry about my visibility. Can you hear me? Is the board visible? Board visible? Why not? There is a network problem with those who are not able to see the board. Students, you will find a video also of that. Don't worry. Alright, just concentrate over here. It's the network problem from your side, beta. My net is everything fine, and few students are also able to see the board very clearly. Okay, so your net connectivity is a problem. Please check it out. Alright, we'll continue. You can see this obtuse angle triangle, the perpendicular is always be outside the triangle. So this EN is going to be perpendicular for triangle BDE also. So on this arm AD, we will find the area. Area of triangle ADE upon area of triangle BDE. See, short form of area is AR. ADE. Can you see that? Which is the base AD and perpendicular EN. So area of ADE half into base AD into height EN. upon area of triangle BDE, half into base BD into height remains the same. As I showed over here, the height remains the same. Height does not change. Clear? So we can see half and half cancel, E and cancel. What will be left? AD upon BD. Equation number first. Half and half cancel, E and cancel. What will be left? Area of triangle ADE upon area of triangle BDE. This is what was required. We have got it. BD we call it or DEB we call it. It does not make any difference. Now we come down on side AC. We want AE and EC. AE and EC. Same thing. ADE. Is it the perpendicular on the side base? This time the perpendicular is DM. Previously the perpendicular was here. We are talking about the same triangle. On side AC, area of triangle ADE upon area of triangle CED. CED. Half into base, which is the base AE, into height, which is the height DM, upon half into base, which is the base EC, and height remains the same. DM is perpendicular on AC, sorry. So half into EC into DM. Again DM cancel, half cancel. What is left? AE upon EC. Area of triangle ADE upon area of triangle CED. Equation number 7. What was required we have on the right hand sides of the two equations, first and second. Clear? The question arises, we have to prove it equal. How to be equal, sir? If the left hand side is equal, will the right hand side be also equal? Definitely. To check the left hand side, area of triangle ADE, area of triangle ADE, it is the same. Numerator is same. Then area of triangle BDE and area of triangle CED. Where is BDE? BDE. See, I am marking it. You be careful. Observe it. Can you see BDE? And area of triangle CED. Area of triangle CED. Can you see this triangle? And this triangle is on the side DE and it is between the same parallel lines. So in class 9, chapter number 9, theorem number 9.1, it says triangles on the same base and between the same parallels are equal in area. Which is the same base? DE. Is it between DE and BC? Yes. So therefore they are equal in area. Class 9. Now here we know triangles on the same base, which is the base DE, and between same parallels, which is the parallel DE parallel to BC, are equal in area. We have proved it, we have done it in class 9. So therefore, area of triangle BDE equals to area of triangle CED, equation number 3. Now check equation first, second, third. First, second, third. Is the numerator equal? Yes, ADE. Denominator BDE and CED. Is the denominator also equal in third? So from equation first, second, third, can we say left hand side is equal? So therefore right hand side is also equal. So from equation first, second and third, left hand side is equal. So right hand side is also equal. AD upon BD is equals to AE upon EC. Hence proved. This is basic proportionality theorem proof. Students, very important proof. And since there are only 2 theorems in this chapter, so the probability of asking this question is more, right? Only 2 theorems are left out of 4, so the probability increases, right? Now the question arises, sir, okay, fine, AD upon BD equals to AE upon EC, fine, but what about AD upon the complete side? Is that also proportional to AE upon this complete side? Yes, we call it corollary of VPT. Corollary 1. What is that corollary? Corollary means related to this theorem, the proof related to this theorem, we can conclude one more part from there, that AD, this part of this side upon the total side AD. AD upon the total side AD. AD upon the total side equals to AE upon the total side equals to AE upon AC. Similarly, second corollary also we can say BD upon the total side is equals to CE upon the total side. BD upon AB is equals to EC upon AC. This we can also conclude. Right? Now this was VPT. What was VPT? Again we call, if a line is drawn parallel to one side of a triangle, the other 2 sides are divided in the same ratio. This was the proof. We will do the application of this in the exercise, but before doing the application, there is a second theorem also, 6.2. Theorem 6.2. We don't need to prove it. Theorem number 6.2. It is converse of VPT. We don't have to prove it. Please check your statements in your textbook, page number 126. Page number 126 of the NCERT book, you can check. What does it say? If a line is drawn, if a line divides any 2 sides of a triangle in the same ratio, then the line is parallel. Here he was saying that the line is parallel, then the 2 sides are in the same ratio. In 6.2 says, if 2 sides are in the same ratio, then the line is parallel. That is why we call it converse of VPT. Clear? So, very, very important how to apply it. Example number 1, you will find proof of the first corollary. Proof of the first theory, first corollary, AD upon AB equals to AB upon AC. Alright? So, you can do it, is not tough. We will come down to the exercise. Let us discuss few questions from the exercise very fast so that you can do. First question. In the given figure, D is parallel to AC, find EC. Can you see that? If a line is parallel, the other 2 sides are divided in same ratio. Can you say AD upon DB equals to AE upon EC? First question, first part. Just cross multiply. You have AD upon BD, AE upon EC. You have to find EC. Cross multiply, you will get EC. Second part also same. AD upon DB equals to AE upon EC. AD is not given to us, rest of the 3 quantities are given to us. You just have to cross multiply and get the answer. I hope you can do it, is not tough. Okay. Now, second question is about converse of VPT. He says E and F are the points on the sides PQ and PR respectively of a triangle PQR. For each of the following cases, state whether EF is parallel to QR. State whether it is parallel or not. So when is it going to be parallel? When is it going to be parallel? If the 2 sides are divided in same ratio. So you just have to divide the sides and check. If the sides are proportional, then the line is parallel. If the sides are not proportional, then the lines are not parallel. Clear? I hope you can do these questions. They are not tough. Okay. I want to discuss second and third question with you. You can see the figure. In both the questions, you just have to observe, students. You don't have to do anything else. Observation is very, very important in geometry. In 9th class also I had told you people, Observation is very important. If you can observe the figures, it is very easy. Check. Third question. In the given figure, LM is parallel to CB and LN is parallel to CD. I'll draw the figure for you. Let me draw the figure. This is one. This is another. This is A and this is B, I suppose. Right? Sorry, this is B and this is C. This is B and this is C. He says LM is parallel to BC. Yes or no? This LM is parallel to BC. I have marked it. So what can I see? Can you see that we have a triangle with a line parallel to one side? If a line is parallel to one side, which theorem is applicable? BPT is applicable. The other two sides are going to be divided in the same ratio. This LN was parallel to which side? Sir, BC. So which are the other two sides left? AB and AC. These two are in the same ratio. Isn't it? Can I say that AM upon BM equals to AL upon LC? Definitely. Definitely. And second figure, another triangle is there. This is D and LN is parallel to ND. Sorry, CD. Again, can we see a triangle with parallel line? LN is parallel to CD. So are the other two sides in the same ratio? Definitely. Just observation. What is given to us? We are given LM parallel to BC and LN parallel to CD. What we have to prove? We have to prove that AM upon AB equals to AN upon AB. AM upon AB, total side. So was it corollary? Here in BPT it was sides were proportional AM and MB, but now when we talk about corollary, it is AM upon AB. Construction not required, everything is constructed for us. Proof. In triangle ABC, AM upon AB, AM upon AB, is it equals to AL upon AC? AL upon AC. Write down the reason. Corollary of BPT. Why it is applicable? Because LM was parallel to BC. Similarly, I will call it equation number first. Similarly, in triangle ACD, in triangle ADC, LN is parallel to CD. So therefore, AN upon AD, AN upon the total side AD is equals to AL upon the total side AC. Equation number second, reason same. Can you see? First and second, right hand side equal, so left hand side also equal. From equation first and second, AM upon AB equals to AN upon AB. Only observation, nothing new. Second, third, fourth question is again the same. You have to draw the figure and you have to observe, nothing more than that. He says in the given figure, DE is parallel to AC and DF is parallel to AE. Let us draw the figure. You can see question figure. This is the figure. A, B and C. The bigger one, right? Then he says DE is parallel to AC. D and this is E. Yes, it is parallel to AC. I'll make it parallel slightly. DE is parallel to AC. Right? So can we apply BPT in this triangle? Definitely, sir. One side is parallel to one line of a triangle. DE is parallel to AC. Then let us don't get confused. Don't get confused. Wait. Write down whatever is visible to you. Given DE parallel to AC and DF parallel to AE. Sorry, DF parallel to AE. What you have to prove? you have to prove that BF upon FE is equals to BE upon EC. The construction and proof. Check. Am I visible? BE upon EC. So this is BE, this is EC. Are these two sides divided in same ratio? In triangle ABC, DE is parallel to AC. So therefore, BD upon BA equals to BE upon EC. Equation number first, by what theorem? By BPP. Can you see that? If a line is drawn parallel to one side of a triangle, the other two sides are divided in the same ratio. Similarly, second one, in triangle ABE. Check. I am removing this line for a time being. Check, in triangle ABE. DF is parallel to AE. DF is parallel to AE. So are the other two sides in the same ratio? So therefore, BD upon DA equals to BF upon FE. Equation number second. BA and BE, two sides are divided in the same ratio. Why? Because DF was parallel to DA. So from equation first and second, can you see right hand side, left hand side equal? The left hand side is right hand side is also equal. BE upon EC is equals to BF upon FE. Only observation, students. Nothing new. You just have to observe the things carefully. I hope you have understood the basic proof of. Please do it in your notebook. Please observe these two questions. Make the figures neatly in your notebook and practice them. Question number first and second. I hope I was able to clear the problems. Clear? And number two, in the next video, we shall also discuss about your rest of the questions of this exercise. Clear? Thank you.